Okay, so today's lesson is going to be broken up into three parts. Part one, we're going to be finding the surface area of a prism. And I started with kind of a nice basic one that we have a little bit more of understanding for. So this is kind of basically a box, right? So this prism is a rectangular prism, which is a box. Now, first off, let's talk about what surface area is. Surface area, so if you imagine this as being a box, right? And you were to paint the box, right? Maybe you were to paint the box blue. Well, all that stuff that you painted blue, that's the surface area, okay? So it's the outer part. So how do we go and find the surface area of a prism? Well, how do we find the surface area of this box that we got here? So the easiest thing is if you've ever broken down a box, right? You can break it down into a two-dimensional shape. So let's go and break this box down. So I'm going to take the first, so let's see what we got here. So looking at our box, right, we have this front face right here, this rectangular front face, and I'm going to just kind of break that out here. Then what do we have? Okay, so if we were to unwind it, so right, if you imagine that front face and we were just kind of unwinding it from there, well now, what would we have? We'd move on to this lateral face or the side face, and that's another rectangle. So maybe looks like, I don't know. I want to make sure it looks like it's different, right? It's not the same rectangle. Then as we move on, I think you'd agree we have this back face right there. So, and that's going to be exactly the same size and shape as the front face, right? So it looks like that. And then finally we have another lateral face, and that is this one, which is exactly the same size and shape as this one right here. So in other words, this. Whoops, a little bigger, huh? Okay. So what I want to do is I want to go and find, let's see if we can go and find some information about this. So first off, if I wanted to find the area of this, I think you'd agree, of this kind of this elongated shape, I would need to know this. I need to figure out what that is, that one long side, what is its length, and then I'd have to multiply it by the height, which we already know is h. Well, that long side, I think you'd agree, the distance from here to here is just L. Then the distance from here to here is W, and then we kind of repeat, right? The next one is L, the next one is W. So if I wanted to go and find the area of this lateral side, right, of these lateral sides, I would take L plus W plus L plus W and multiply it by the height. Now, you might be saying, well, wait, there's two more pieces. There's the top and the bottom. Absolutely. Those are the bases, right? And those bases are also rectangles. So they look something like, what do they look like? They look like this. So there's two of those bases. And I'm kind of making this up because I don't know exactly what those bases look like. They don't necessarily look like the side pieces, right? They may coincidentally, in this case, look kind of like them, but they don't have to be. So, and what are they? Well, they are L by W, and there's two of them. So what we would do, let's see, hopefully this one isn't longer. I don't know if it is. I have two of these. I think this one's, is this too long? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Too long. Whoops, and now I've just erased everything. So let's see. 3, 4, 5, 6, 7. I want to make them look the same. I mean, I know hopefully you guys understand what's going on here. Okay. So here's right, if we wanted to go find the area of this entire shape, I would add the area of each of these pieces and get it. Now you might say, well, that's kind of a pain. And I agree with you. That is kind of a pain. I don't want to do that every single time. So what can we do to make this shorter? Well, first off, we can recognize that we can kind of break this up into two distinct pieces. So this right here, let's do this in pink. This piece right here, that's called the lateral area, right? And the lateral area is a rectangle with a height h. Now the base of this rectangle, right, we said is L plus W plus L plus W. But notice what L plus W plus L plus W, what is that? Well, that is the perimeter of that bottom rectangle. In other words, it's the perimeter of that base. So this whole thing underneath here, right, that L plus W plus L plus W could all be considered the perimeter. And then, of course, we have the height. So if I wanted to put this together and create a formula for the surface area, so I'm going to call the surface area S, then the surface area would be the lateral area, right? The lateral area, which is the perimeter, times the height, right? That's the area of this gigantic rectangle. And then what would I do to it? I'd also have to add the two bases. So plus the two bases. Okay, so that's how we find the area of a rectangular prism. But the question might be, well, does that always work? Do we always take the perimeter, multiply it by the height, and then add the two bases? I don't know. Let's go and look at another example then. So now I'm going to look at this triangular one. Okay, so I'm going to look at this triangular piece. So if you notice, again, we have a top and a bottom, our two bases, and then we have this lateral side. So again, let's see if we were to break this up again. So we have our two bases, and I'm gonna, if you don't mind, I'm gonna just draw two triangles that are not correct, just because it's kind of hard to draw these triangles. So I'm gonna just draw these two triangles. So these are my bases, right? Those are my bases, whatever the area of those bases are. But let's talk about the lateral. So if we were to unwrap this, again, notice what we'd have. We'd have three rectangles, right? So actually, let's unwrap this. Whoops, I didn't mean to do that. So we have three rectangles. Okay, so rectangle one, as you can probably see, would be this front face. And what is it? So let's kind of look at it. So it's got a bottom part, right, of A, and it's still got a height of H. Then as we continue to unwrap this, right, so let's make this next one, I'm going to make it look like it's different. So this next one, right, as we go to unwrap it, again, so now I'm looking at this side. Well, it's got a bottom part of B, and its height is still H, I think you'd agree. And then there's this third side, right there. And let's make it look even different again, because they don't have to be the same. So it's got a bottom part of C and a height of H. So what do we notice? Well, A plus B plus C is going to be one dimension of this rectangle, and H is going to be the other. But A plus B plus C is our perimeter, right? So again, if I want to find the area of this prism, right, I would take, in order to find the surface area of my prism, I would take my lateral area, again, this piece, which is the perimeter times the height, and I'd add it to the area of the two bases. Okay, so it looks like so this is our formula. This is the formula that we're going to be using for all the prisms that we're going to be dealing with. So it's the lateral area, which is perimeter times height, plus the two bases. So let's go and look at some concrete examples instead of using just letters here. So let's look at, let's go and look at this one right here. Okay, so let's go find the surface area of this shape. So in order to find the surface area, let's think of what we need. Well, we need to know what is the perimeter. Okay, well, the perimeter, I think you'd agree, is this distance around this base. Okay, which is, well, if I were going to put in some numbers here, let's put in some extra numbers here. I know you guys can see it, but let's just put them in. I have 2 8s and I have 2 6s, right? So my perimeter is going to be equal to 2 times 8 plus 2 times 6. Okay, so that is the perimeter of that shape. And if we were to simplify that, right, that would be equal to 28. And that equals our perimeter. Okay, so 28 centimeters. Now, the height is given. The height is just 12 centimeters. And then, of course, we have our bases, right? There's 2 bases, but one of the bases, so if we were to look at, again, the area of that base, that's just 6 times 8. 6 centimeters times 8 centimeters, which would be equal to 48 centimeters squared. So if we want to go and find the surface area, right, well, let's think about what we have to do. So the surface area is going to be equal to the perimeter times the height plus our 2 bases. So our perimeter is 28 centimeters times the height, which is 12 centimeters, plus our 2 bases, which is 2 times 48 centimeters squared. So what do we get? In total, when I do this, I'm going to get 400. Well, actually, let's kind of break this up a little bit just to make sure we're okay. This part is just for the units, just to make sure you're okay with the units. So 28 times 12 is 336. So this is going to be 336. Centimeters times centimeters is centimeters squared. And of course, 48 times 2 is 96 centimeters squared. Notice when I add these together, the units are going to stay the same. So it's going to be a total of centimeters squared. So our final answer is going to be 432 centimeters squared. So surface area, because we're talking about area, our units are squared units, unlike volume, which are cubed units. Okay? So that's for the first one. Now let's do a triangular prism. So let's look at this one now. So remember, the idea is exactly the same. Okay, so the idea is exactly the same. So we need to know the perimeter. So let's look. The perimeter in this case, I think you'd agree, I'm going to just use this top one now, is the length of the distance around the pink, right? The distance around that base. So in order to do that, I think you'd agree we have 2 sides. We do need to know the third side. I'm going to just call that third side X because we don't know it. But we do know it's a right triangle. So in other words, if I want to find X, I think you'd agree that would be 10 squared plus 24 squared equals X squared. And 10 squared plus 24 squared is 676, which equals X squared, which means X equals plus or minus, 26? But of course, we only want the positive root. So it is going to equal 26 inches. So let's go and do our thing. So our perimeter is going to be equal to, so we're going to add 10 inches plus 24 inches plus 26 inches. That's our perimeter. And that whole total is 60 inches. Our height, we already was given to be 20 inches. And then the area of our base, if we want to look at one of our bases, that's a triangle. It's a right triangle. So it is 1/2 base times height, or 1/2 10 inches times 24 inches, which is going to equal a total of 120 inches squared. So now, in order to go and find the surface area, right? Our surface area is, it is the perimeter times the height plus 2 times our bases. So our perimeter, we said, was 60 inches. Our height is 20 inches. And then our 2 bases is 2 times 120 inches. Okay? Squared, excuse me, because those are squared units. When we are finished and we add those things all together, we are going to get 1,440 inches squared. Okay? And that is the end of part 1 of our surface area lesson.